Good afternoon, viewers. Once again, day before yesterday, we are discussing in the science class. Today, we just continue our discussion on the same subject, science. So, I remember we stop our discussion in the previous class with the SI system. So, there are different system of units as we know, which are CGS system, FPS system, MKS system. So, then along with the 3 fundamental quantities, 4 more basic quantities are added in 1960 and framed a new system of units. We call it as a SI system. So, I also inform about the abbreviation of SI means System of International Derived Units or International System of Units. Now, in SI system, the advantage is in all the 3 other systems only there are 3 fundamental quantities are there. So, in SI system scientists may prepare 4 more basic quantities and list the 7 fundamental or basic quantities as I explained in the last class. Once again I want to reveal those. One is the length, which is expressed in terms of a centimeter. Another one is a mass, which is expressed in terms of a kg. One is the time, which is in terms of a second. Temperature, degree Kelvin, electric current, ampere, luminous intensity, candela, amount of the substance as mole. Adding to these 7 basic units, 2 more supplementary quantities are also added in the SI system. So, as I reveal, so along with the 7 basic units, 2 more supplementary quantities. Supplementary quantities are also added. So, which are number 1 is plane angle, one more it is solid angle. So, the unit used to represent the plane angle is radian and the corresponding unit used to represent the solid angle is steradian. So, these are the few basic quantities in case of a SI system. In the examination you can expect write down any few fundamental quantities with their units for 3 marks. You can write any 3 fundamental quantities like even length, mass, time are also sufficient. Suppose they expect any 5 fundamental quantities with their units. So, you can write any 5 out of the 7. In some examinations more specifically asks write down the 2 supplementary quantities with their units according to SI system. In such a time you just write plane angle and solid angle. So, the advantage of the SI system is in all the other systems we have only 3 basic quantities, 3 fundamental quantities. Here we have a 7 fundamental quantities and along with those 7, 2 supplementary quantities are also there. Now, the thing is, so if it is a international system, for use of this system, is there any rules, is there any conventions to be followed? There are many conventions to be followed while following the SI system. So, few of them which are useful in your future classes, I will explain them little bit simply. So, number 1 is suppose to read one paragraph for a student, he consumes a time of about 16 seconds. You also know 16 is a plural form. 16 seconds is a plural form. Seconds, it is a unit used to measure a time, where time is a physical quantity. Even though we are expressing the plural form of a physical quantity, we don't write the plural form of that physical quantity. Even though it is a plural form 16 seconds, you write it as a 16 second. So, you avoid the plural form even though physical quantity is large. For example, so to shift the object from one place to another place, work has to be done is So, suppose any plural form, even though it is a plural form, do not write the plural form. What is the mass of the object? If it is a 50 kilograms, you just write 50 kilogram only. So, avoid the plural form even though object is large. So, that is the first convention. One more convention is, suppose you are going to write the unit for a physical quantity. Suppose that unit represents the name of any person, maybe a scientist. For example, ampere is a unit used to express the electric current, where ampere is a name of a scientist. While writing 5 ampere, if you want to write the complete, there is a 5 ampere of current flows in the circuit. If you want to write the full name of the unit, start the name of that unit with a small letter. If the unit of a physical quantity represents the name of a person, if you want to write full form of that unit, start to write that unit with a small letter. Suppose if you want to express this unit symbolically, so write down, so the capital letter for the first letter of that word. A is the first letter of the word ampere, that is why I will put 5 ampere. So, suppose the force applied on something is about 10 Newton. In SI system, force is expressed in terms of Newton. Once again, Newton is a name of a scientist. If you want to write the complete form of the unit, start that one with a small letter. Start that one with a small letter. If you want to represent it symbolically, write down the first letter of the capital, first letter as a capital of that starting letter of the word. So, this is also one of the convention. Avoid the full form of, avoid the plural form of a physical quantity. So, if it is a name of a person, if you want to write the complete unit, start with a small letter. If you want to write the unit symbolically, if it represents a name of a person, just capital letter of the starting letter of that word. So, you just follow these two convention while following the SI system of units. Now, the question is, is there any advantages of SI system? Definitely, if not any advantages, it will be never called as a SI system. So, what is the, you just concentrate our interest on which are the few important advantages of the SI system. One more thing, from the examination point of view, in most of the question papers, so there is a question on this concept for only 2 or 3 marks. Write down any 2 uses or any 2 advantages of the SI system. There are many advantages. So, few of them are, so first of all, name itself indicates how much standardly it is used. It is a system of international unit. I mean, it is internationally accepted system. So, throughout the universe, every nation should follows this system, that is why it is called as a system of international derived units. What is the advantage of using this every nation of the universe? Only the thing is, if there is any work on the science and technical field taken place in any country, so some other country want to reveal that work. So, whatever may be their language, they are writing in terms of English or any other Chinese language, anything, the units should be expressed in terms of SI system only. I mean, there is no question of confusion. At the same time, it consumes the manpower. So, if some country used CGS system, some other country used FPS system, someone used MKS system, if there is any if there is any technical works or scientific works searched by any other country, they just convert the physical quantities to the followed by their country, then only they can go through the work done by the scientists belongs to other country. So, it avoids that sort of confusion. So, the first advantage is it is international standard system. This is the one of the important advantage of the SI system. One more, it is in science, in nature, we can observe different forms of energies, say mechanical energy, electrical energy, solar energy, heat energy, etc. In case of CGS system or MKS system, FPS system, for each form of energy there is a separate unit. I mean, in MKS system, heat energy is expressed in one system, one unit, heat energy is expressed in one unit. So, electrical energy is expressed in some other unit. So, solar energy is expressed in some other unit. I mean, for each forms of energy, there are different units are used. But in case of the SI system, if it is a energy, whatever may be its form, we never bothered whether it is electrical energy, mechanical energy, chemical energy. If it is a energy, then its unit should be expressed in terms of joule. So, please note that joule is a unit in SI system to express all forms of the energy. Once again, it avoids the confusion, conversions, etc. So, what is the one more important advantage of the SI system is, so all forms of energy are expressed in terms of a single unit, we call it as a joule. Then, so in nature, while measuring the physical quantities, there are some small physical quantities are available, very large physical quantities are available. For instance, I want to explain with some simple example. So, you may heard the photoelectric effect or not, you can study the concept of photoelectric effect in your future classes under the chapter of modern physics, do not worry. Photoelectric effect is simply a phenomena of emission of electrons from the photosensitive metal surface by the influence of the light energy. This is called as a photoelectric effect. So, to conduct the photoelectric effect, the time consumed is found to be 0. This is the time required for photoelectric effect. You just imagine. So, in case of photoelectric effect, light should be falls on some photosensitive material. In that photosensitive materials, electrons absorb the light and coming out from that orbit. Then emitted electron should accelerate towards the anode, and there is a flow of electric current in the circuit. For all this process, the required amount of time is found to be 0.00 like this 1 second. This is the very small time, but it is a measurable. So, to express very small physical quantities of this type, so there is a scope, there is a facility in case of the SI system. Instead of expressing this should be expressed in terms of a 10 to the power of something. For example, this is 10 power minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, 9. This is equal to 1 into 10 power minus 9 second. So, if you have a label for this 10 power minus 9, say in SI system this 10 power minus 9 is call it as a nano. Then what is the time spent to observe the photoelectric effect? You simply say 1 nanosecond. You just observe how much comfortable it is. Is it clear? So, to conduct the photoelectric effect taken place within a span of 1 nanosecond. I mean, we do not worry about the photoelectric effect, you just worry about this is a very short, very small physical quantity. So, nano is one of the submultiple in case of the SI system. By making use of that submultiple, we are able to write the very small measurements comfortably like this. I mean, so the this advantage is whether the given physical quantity is a very small or very large, we can express it comfortably by using submultiples and multiples in case of the SI system. So, few of the submultiples I am going to write, so please watch. So, list of submultiples which are used in SI system. So, number 1 is 10 power minus 1, it is labeled as deci. 10 power minus 2, it is called as centi. 10 power minus 3, it is milli. 10 power minus 6, it is micro. 10 power minus 9, it is nano. 10 power minus 12, it is pico. 10 power minus 15, it is femto. 10 power minus 18, it is atto, like that. I mean, there are a list of submultiples are available in case of a SI system which are used to express the very small physical quantities comfortably. So, analogous to if there is any scope for expressing the small physical quantities comfortably, so there is a scope also there to express the very large physical quantities also comfortably there. So, you can say 10 power plus 1, it is deca. 10 power 3, 10 power 2, it is hecta. 10 power 3, it is kilo. 10 power 6, it is mega. 10 power 9, it is giga. 10 power 12, it is tera, like this. So, suppose the measured physical quantity, its measured physical quantity has a very large magnitude. So, this large physical quantity you can express comfortably by making use of the multiples. So, one more advantage you can quote like this: in case of a SI system, it is very comfortable to express very small physical quantities and very large physical quantities by making use of the submultiples and multiples respectively. You can quote these three advantages. I think it may be sufficient even for the examination point of view also. So, I just repeat what are the advantages of the SI system is. First of all, it is a internationally accepted standard system. Throughout the universe, this system will be follows. This is the first advantage. The second advantage is, so all forms of energies in SI system is measured only in terms of joule. The third advantage is, whether the physical quantity is very small in magnitude like this or very large in magnitude, it can be expressed by using the submultiples or multiples respectively. This is about, so the according to your syllabus, so discussion on the units. Now, let us concentrate our interest on dimensions of a physical quantity. It is not one more chapter, it is coming under the same chapter. So, dimensions of a physical quantity. What do you know about the dimension? The concept is very simple. Suppose in general, I want to tell one small example. Your parents are required to purchase some site in some area. They call the site broker and said, in this area we need a site. Broker immediately asks, so what is the size, what is the dimension of your site you require, sir? Like that. So, immediately, most familiarly, so the people will choose the site of the size 30 into 40. It is called as a dimension of the site. So, what is this 30 stands? What is this 40 stands means? 30 is the length of the site. It should be multiplied by 40 is the breadth of the site. We know that length into breadth, we call it as a area. We call it as a area. So, area of your site is 30/40. We call 30/40 as a dimension of that site. What is the dimension of the area? Now, the question is, so L, length is L, breadth is another form of a length. So, instead of B, I want to write L for my convention. L into L, you can say L square. So, what is 2? 2 is the power raised on the L. What is L? L is the fundamental quantity. So, that 2 is called as a dimension with respect to this example. So, then what is the dimension? So, it is simply power to be raised on the fundamental quantity, power to be raised on the fundamental quantity to express the unit of that physical quantity. So, dimensions of any physical quantity you can define like that: powers to be raised on the fundamental quantity to express the unit of that physical quantity. So, usually in most of the cases, so we use only 3 fundamental quantities, that is length, mass and time. With respect to your syllabus preferred only the physical quantities whose dimensions should be limited to length, mass and time. Do not worry about the rest of the basic quantities which are described in case of the SI system. So, now with respect to what are the powers raised on the fundamental quantity, length is 2, right. So, what about the mass? We are not at all using the mass to define the dimension of area. What about time? We are not at all using the time to satisfy the definition of area. So, in here one more convention is, while writing the dimension of any physical quantity, so use the capital letter L for length, M for mass and T for time, right. So, with respect to this, what are the dimensions of area means, you can say L square, because L is used twice, M is used none, T is also not at all used, that is why M to the power of 0, T to the power of 0. So, now you can say dimension of area is, the dimension of area is 2 in length, 0 in mass and 0 in time. So, I repeat, dimension of any physical quantity is equal to powers to be raised on the fundamental quantities to express the unit of that quantity. Now, how to represent the dimension of a physical quantity? While writing the dimension for any physical quantity, so you just write that physical quantity inside a square bracket. For example, here we are writing the dimensions of area. So, instead of writing only area, if you put some square bracket for area, so you read now this one as dimensions of area. Square bracket represents dimension of that physical quantity. Now, we know what is the dimension of area. What is this? This is also put inside the square bracket like L square M 0 T power 0. Therefore, you can say dimensions of area are 2 in length, 0 in mass, 0 in time. This is the one of the convention to be followed while writing the dimensions of a physical quantity. Now, this final expression, it is referred as a dimensional equation or dimensional formula. Dimensional equation or dimensional formula. Now, the thing is, how can you define this dimensional equation? The answer is, you just observe the LHS and observe the RHS. With respect to this example only, similarly all the examples follows this. LHS is area, so definitely it is a derived quantity. RHS, it is L to the power of something, M to the power of something, T to the power of something, all are fundamental quantities. So, this is referred as a equation of a formula. What it says is, it connects the relation between the derived quantity and a fundamental quantity. That is all. Any equation, any formula which connects the relation between fundamental quantities and derived quantities, it is called as a dimensional equation. What is a dimensional equation? Write the dimensional equation of area. So, this is for 3 marks. Definition of dimensional equation is for 2 marks. Writing the dimensional equation for area is 1 mark. You can say any equation which connects the relation between the derived quantity and a fundamental quantity, you can refer it as a dimensional equation. So, write the dimensional equation of area in the form of L power 2 m power 0 t power 0. Take care, it should be written inside a square bracket. Now, what are the steps to be followed to write the dimensional equation of a given physical quantity? So, while writing the dimensional equation of a given physical quantity, first define that physical quantity according to their definition. For instance, so what is the dimensional equation of a volume? The question is, write down the dimensional equation of a volume. So, basic definition of volume you want to recall. What is the basic definition of the volume? It is simply a product of length, breadth and height. So, it is L into B into H. Write down the definition on the right hand side to the fundamental, to write down the definition of the right hand side using the fundamental quantities only. Length is a fundamental quantity. Breadth and height are the different forms of the length. Therefore, it is ready in the form of a fundamental quantity. It is a L into L into L. It is simply L cube. Now, this fundamental quantity, derived quantity expressed in terms of a fundamental quantity. Then you just to finish with a addition of all other fundamental quantities for writing the dimensional equation of this physical quantity. So, you read dimensional equation of volume, which is 3 in length. While writing the dimensional equation of any physical quantity, use the capital letters for length, mass and time and all other fundamental quantities. So, we are not using the mass, therefore, it is m power 0. We are not using the time, therefore, it is t power 0. This is the way convention to be followed to write down the dimensional equation of any physical quantity. I repeat, while writing the dimensional equation of any physical quantity, first of all define that physical quantity according to their definition. Observe whether definition represents the fundamental quantities only, then fulfill the final work, write that in terms of a square bracket and write down the dimension of that physical quantity is dash in length, dash in time, dash in mass, like that. So, there is a one of the possibilities such that while writing the dimensional equation of the given physical quantity, in the first step after their definition, the obtained physical quantities on the right hand side may not be a fundamental. For instance, so there may be a question to write down the what is the dimensional equation of a momentum. This is also one of the physical quantity, of course, derived physical quantity, which may discuss in our future classes. Do not worry about the word momentum. Momentum is one of the physical quantity. For at that instant, you can know what is the momentum means, it is a physical quantity. How can we define according to their definition? It is simply a product of mass with its velocity. Now, we are defining the given derived quantity which is required to write their dimension. We are going to write the dimension of the momentum. In the first step, we are defining the momentum according to their definition. Observe the right hand side, mass is the fundamental quantity, but velocity is not. You can write mass as capital M, our job is over, but what about velocity? Velocity is not a fundamental quantity. So, again define that derived quantity. Till you have to follow this convention, it should be in terms of fundamental quantity only. For example, here it is mass, it is a fundamental quantity, do not disturb it. We know that velocity, it is a ratio of displacement made by the body to the time taken by the body. So, displacement, it is nothing but a s, time taken, it is t, right. So, s is displacement means it is a distance, distance means it is a length, it is mass, it is length, it is time. So, now the right hand side is in the form of a fundamental quantities. Now it is now it is very easy to write the dimensional equation of the momentum. Put the momentum inside a square bracket. Now you can read this one as dimensional equation of a momentum. So, on the right hand side we are using the S. S means length. So, S means L. Yes, L is used only once, you can say L power 1. Mass of the substance is also used, it is m power 1. T, when it is goes to the numerator, its power changes to -1. Now, the dimensional equation of momentum are 1 in length, 1 in mass and -1 in time. So, this is the convention to be followed while writing the dimensional equation of a given physical quantity. From the examination point of view, at least you have got 2 marks in writing the dimensional equation of a physical quantity. So, what is dimension? What are the conventions to be followed to write the dimensional equation? On that way only we are complete the dimensional equation of area. So, it is 2 in length, 0 in mass and 0 in time. Dimensional equation of volume. So, it is 3 in length, 0 in mass, 0 in time. Dimensional equation of momentum, it is 1 in length, 1 in mass and -1 in time. Analogous to this, there are few simple dimensional equations are there. I just to define those dimensional equation one by one, you just watch, if possible you can note down. So, dimensional equation of a frequency. So, usually frequency can be defined as a reciprocal of a time. So, you can write, so reciprocal of time. So, therefore, dimensional equation of frequency, I just write symbolically. Here length is not used, mass is not used. You can write L power 0, m power 0, t power -1. So, dimensional equation of frequency are 0 in mass, 0 in length and -1 in time. Now, you can write the dimensional equation of a density. So, define the density according to their definition. It is a ratio from mass to the volume. Density is equal to mass divided by volume. Therefore, dimensional equation of density, which is equal to, observe the RHS, here mass is the fundamental quantity, no problem. Volume, it should be in terms of length, breadth and height, it is L cube, is it not? When L cube comes to the numerator, it becomes L power -3, mass is used once and T is not used, therefore, it is 0. Therefore, dimensions of density are -3 in length, 1 in mass and 0 in time. Now, you can write the dimensions of velocity also. So, velocity can be defined as the ratio of distance travelled by a body to the time taken by a body, that is distance divided by time. Distance is a length, time is a fundamental quantity, no problem here. Therefore, dimensional equation of velocity, which is equal to 1 in length, 0 in mass and -1 in time. 1 in length, 0 in mass, -1 in time is the dimension of velocity. Similarly, so what is the dimensional equation for acceleration? So, we all know acceleration is nothing but a rate of change of velocity. I mean, it is velocity divided by time taken. but velocity means it is a ratio of distance travelled divided by time. So, when it is coming to the denominator, t into t becomes t square, Therefore, dimensional equation of acceleration is s is length, 1 in length, mass is not used. So, t come to the numerator, it becomes minus 2. Therefore, dimensions of acceleration are 1 in length, 0 in mass and minus 2 in time. Then velocity, acceleration, you can write work. How can we define the work done means? So, it is a product of force applied. Under the influence of force, what amount of displacement made by the body, its product gives the work. But force is not a fundamental quantity. So, you can define force further according to Newton's second law as mass into acceleration, right, into d. Again, mass is fundamental quantity, distance is also, displacement is also fundamental quantity. Again, acceleration is not a fundamental quantity. You can write m into acceleration is rate of change of velocity, divided by time into d. Again, this is so this is m into v means s divided by t into d. Again, t comes to the denominator, you can say d into this t coming to the denominator becomes t square. So, it goes to the numerator, it becomes t power minus 2 into s into m. So, therefore, dimensional equation of work or how many lengths are the distance and s is also length, L into L is L square. M is used once, it is m power 1. So, t is to the power of minus 2. In this fashion, you may write down the dimensional equation of a given physical quantity. Now, you can say dimensional equation of length or dimensional equation of work are 2 in length, 1 in mass and minus 2 in time. So, see, by following this convention, you can write down plenty of dimensional equations. So, the convention is similar, only the thing is you have to point to be noted is while writing the dimensional equation of a given physical quantity. So, first of all, write that physical quantity in terms of a fundamental quantity. In the first step, so it is defined, but the defined quantities on the right hand side are not the fundamental quantities. Try to define those derived quantities again in terms of a fundamental quantity, then apply the convention to be followed to write the dimensions of the physical quantities. By following this convention, you may work out so remaining other fundamental quantities, because here I am supposed to complete so many concepts, that is why. So, I just explain how to write down the dimensional equation of a given physical quantity. You can follow this one and complete the rest of the dimensional equations of the physical quantities. Now, is there any advantages or uses in case of a dimensional equations? Definitely, why not? There are many uses are there in case of a dimensional equation. So, in the field of science and research, there are many formulas are framed every day. So, out of many methods to check the correctness of that new formula or given formula, one of the technique you can adopt is idea of the dimensional equation. So, the conclusion is the knowledge of the dimensional analysis is used to check the correctness of the given formula. For example, we all know the famous Einstein's mass energy relation E is equal to mc square. E is equal to mc square. So, if it is a formula, you can check whether this formula is correct or not. How can we check? So, consider the LHS, write down its dimension, call it as a equation 1. Now, recall the RHS, write down its dimensions, then call it as equation 2. If the equations 1 and 2 are one and the same, then the formula E is equal to mc square is correct. For example, LHS. What is LHS? E. E means energy. Energy means work done. Both are the same concepts in physics. Energy means capacity to do work. Energy and work has the same unit and same dimensions. We know that. How can we define the work now only? It is a product of force applied with the distance travelled by the body. Now, what is the force? It is the mass into acceleration. So, what is acceleration? It is the velocity divided by time taken. What is the velocity? It is the distance travelled divided by the time taken, right. So, first you write the D here, then S here, M here. As explained earlier, when t comes to the denominator, it becomes t square. When it goes to the numerator, it becomes t power minus 2. Therefore, dimensions of LHS, which is equal to, so it is L, it is also L, L square m power 1 t power minus 2. Call this one as equation 1. Now, coming to the right hand side, what is the right hand side? It is mc square. M means mass of the substance. So, no confusion about it, it is a physical fundamental quantity. What is c means? It is a velocity of light, whatever the velocity may be, basically it is a velocity. So, how can we define the velocity of light? It is simply by, so distance travelled divided by time taken. It is m. So, this square is applicable for both numerator and denominator. It is s square by t square. So, you can write this one as s first square. So, m next, t when it comes to the numerator, it becomes minus 2. Therefore, dimensions of the right hand side is, which is equal to, s means hence L square, m power minus 1 and t power minus 2. Call this one as equation 2. Observe the RHS of equations 1 and equations 2. Equation 1 has an RHS in the form of L square m1 t minus 2. Equation 2 has an RHS in the form of L square m1 and t minus 2. So, if both the RHS are same, therefore, their LHS must be. So, by comparing the equations 1 and 2, you can say LHS is equal to RHS. So, therefore, this formula is correct. So, one of the important advantages, it is used to check the correctness of the given equation. So, from the examination point of view also, it asks in few question paper, using the dimensional analysis, check the correctness of any one of the equation. E is equal to mc square, P is equal to h dg, F is equal to 1 by T, T is equal to 1 by F, like that. If you understand the concept, then rest of the job is very easy. So, it seems to be so bigger, but when you understand the concept, you can follow yourself. Now, this is the one of the advantage of the dimensional equation. Now, let us concentrate on the other advantage of the dimensional equation. So, one more advantage is, so already you completed the trigonometry discussion in the first semester itself. In the first chapter of your trigonometry, angle and its measurement, you derived one small derivation, that is pi radian is equal to 180 degree. I hope you may recall. What this equation indicates means, so it is the equation which connect the relation between degree and radian. What is degree? It is a unit of an angle. What is radian? It is also a unit of an angle. Then what is the use of this equation? This equation connects the relation between degree and radian. In other words, if there is any physical quantity, for that physical quantity, if there are more than 1 units, then you can connect the relation between those 2 units in the form of an equation. This is the equation which connect the relation between the 2 different units, radian and angle. So, both represents a angle. Now, what is the advantage? It is very simple. So, if the angle is given in terms of a radian, at some instant you want that in terms of a degree, you can convert it. Suppose the angle is given in terms of a degree, if you want to convert it in the form of a radian, you can. So, this is the advantage of having an equation which connects the relation between the 2 different units of the same physical quantity. So, if it is if you are unable to recall this one, you can say 1 meter is equal to 100 centimeter, 1 kilogram is equal to 1000 gram, 1000 meter is equal to 1 kilometer, like this. You see, meter and centimeter are the 2 different units representing a physical quantity, length. So, if you know this relation, suppose length it is given in terms of a centimeter. So, if you want, you can convert it in terms of a meter. If the length is given in terms of a meter, you can convert, if you want, you can convert that in terms of a centimeter. I mean, by using a dimensional equation, these sort of possibilities are possible. I mean, what is the one more advantage of a dimensional equation is, it is used to connect the relation between the 2 different units representing the same physical quantity. So, one more advantage of the dimensional analysis is, it is used to connect the relation between the 2 different units, both are representing the same fundamental quantity. What is the advantage? So, you can interconvert each other with respect to the situation. So, much more you can say, so Newton is the SI unit of force and dyne is the CGS unit of the force. You can convert the relation between these two. 1 Newton is equal to 10 to the power of 5 dyne, like this. These are all the possibilities by following the dimensional analysis. By writing the dimensional equations for both the sides, in all these equations you can derive the relation, but with respect to the shortage of the time. So, you just recall this sort of the advantage from the examination point of view also. It is used to connect the relation between the 2 different units which representing the same same physical quantity. This is one of the advantage. So, one more advantage you can say is so as I write few dimensional equations for the few physical quantities, you can say area depends length, does not depends on mass, does not depends on time. Velocity depends on length and also depends on time, does not depends on the mass. Acceleration does not depends on the length, does not depends on the mass. So, does not depends on the mass, but depends on length and time. So, you can say momentum depends on length, mass, time. I mean, by studying the dimensional equations, you can say to what extent any derived quantity depends on the fundamental quantities. Either it is depends on only length, either it depends on only mass, or all the above, like that, is it not? This is also one of the advantage. So, from the examination point of view, you can write the advantages in this form of the, it is used to check the correctness of the given equation. So, by using the dimensional analysis, it is possible to connect the relation between the 2 different units representing the same physical quantities. So, from the dimensional analysis it is possible to know to what extent any derived quantity depends on the fundamental quantities. These are all the few advantages. If there is any advantage, few disadvantages are also there. So, in case of dimensional equation also there are few disadvantages. From the examination point of view only, I will briefly explain those disadvantages. So, while explaining a loss, so something is directly proportional to some other thing, something is inversely proportional to some other thing, like that, is it not? We are already framed so many laws in the form of Ohm's law, Coulomb's law, etc., etc. While removing that proportionality constant according to law, on the right hand side you have to join some proportionality constants. I hope you may have an idea about the stating the laws, writing the laws, and removing the proportionality constant, putting the equations equal sign and put something to balance on the right hand side. For that proportionality constant, dimensional analysis or dimensional equation is not possible. This is one of the disadvantage. Dimensional equation is not possible for the proportionality constant. One more concept is, while checking the concept of the given equation, if the given equation is in the form of a composite function, I mean, so the right hand side of the equation is in the form of sum or difference of two or more functions, like V is equal to U plus AT. I think this may be a very familiar for you in case of the equations of the motion. So, S is equal to ut plus half AT square. So, the equations of this kind, in general, if the right hand side of the equation consists of sum or difference of more than two terms, you can say dimensional equation is not possible for such a composite functions. This is also one of the disadvantage. One more disadvantage is, you are going to check the correctness of the given equation. So, that equation contains a trigonometric function, say for example, y is equal to r sin omega t. Here y is the displacement, you can write the dimension, r is the amplitude of vibration, you can write the dimension, omega is the angular velocity, it is possible, t is the time, it is possible. What about the sin? It is a trigonometric function. If the given equation consists of a trigonometric function, dimensional equation is not possible for that. Similarly, if the given equation contains exponential functions, logarithmic functions, for such functions dimensional equation is not possible. These are few disadvantages in case of the dimensional equations. I just once again reveal the limitations or disadvantages of the dimensional equations are. So, it is not possible to write the dimensional equations for the proportionality constant. One more is, dimensional equation is not possible for the equations which contains two or more terms in the form of sum or difference, like as I show. So, at the same time, if the given equation involves trigonometric functions, logarithmic functions, exponential functions, etc., for those also dimensional equation is not possible. From the examination point of view, you can recall what is the dimensions of a physical quantity, how can you write the dimensions of a physical quantity, what are the advantages of the physical quantity, what are the disadvantages of the physical quantity. There are few quantities like numbers, proportionality constant, etc., they are not possesses any dimensions, they are called as the dimensionless quantities. So, with this we stop our discussion at this stage. In the next class, I may continue the discussion with the measurement, that is the last corner of this first chapter. After completing that, so we can concentrate on the next chapter. Thank you one and all.